Welcome to DESI ASTRO. So in this tutorial, our objective is to learn that how to extract astronomical fits spectra uh, from a data cube. So your spectra is basically flux versus wavelength obtained from astronomical object using a spectroscopy, and data cube is the collection of a spectra from the each location of the galaxy or astronomical objects. Alright, so stacking fits spectra is a technique in which we combine our multiple one-dimensional spectra into a single spectra, and which improves the signal to noise ratio of the spectra. So how it works? Astronomical observation, the noise is the random, okay? So and whereas the signal is very much consistent. So by stacking multiple observations from the spectroscopy, the random noise can be minimized or it may cancel out, while your signal will get stronger. So this automatically leads to a higher SNR, and which uh, will be useful in case of detecting your like very faint features in emission or absorption lines. Now I will be discussing methods to stacking your bits spectra. So you can do simple averaging. So just take say 5 spectra, and like you average the flux of your each spectra and combine into one. So similarly you can do a median stacking. So you can take care of outliers. You can do weighted averaging, in which like each flux is given some weight as per uh, the strength, and finally you can do some noise weighted averaging. Okay, so this you can do uh, with the error in the flux. Okay, with that. So here we can visualize that what we are going to do. So let me run this line. So here you can see that our data cube, a Spaxel X and Y, row and column, and for each XY Spaxel we have a spectra, and you can see some emission lines and some absorption lines, right? So this contains a lot of spectra, say 500 spectra is in my data cube. So what we have to do? So stacking means that we have to combine these all spectra by any one of above methods, and we have to obtain a single spectrum out of this. Download the MANGA data cube for this tutorial. So either you can go to this website, or alternatively you can watch my earlier tutorial on how to download SDSS MANGA data cube in FITS format. So for that you can watch my video on the given screen, and I have also attached the video link in the description, or else you may watch by clicking on the top right corner of this video. So now we'll be doing the same stuff using Python coding. So let's start. So first of all I will import some necessary libraries. So import libraries. So I will import Astropy. So from Astropy dot input output import fits. So this will deal with your fits file handling, right? And then you can import numpy for taking care of numerical stuff and array handling. Then you can import matplotlib for your Python plot visualization. dot pi plot as PLT, right? So this is the library we need to do mat matplotlib, right? Now it's fine. So we need at least 3 libraries for time being. Now we'll read our data cube, okay? So read, or maybe just first open fits data cube, right? So fits data cube. So you can call here cube, and you can give command fits dot open and function, and you can give here a file name, okay? So in my case, my data cube is this one, right? So you can extract the information. So extract cube information. So you see that where your uh, spectra is, right? So here you can see that your flux is in your first HDU, and your wavelength is in the fourth HDU, okay, right? And we have spectral shape 74, 74, and we have wavelength axis 6732, okay? So let's just check flux and wavelength, okay? So extract flux and wavelength, okay, right? So for that, what we'll do, we'll type here say flux, right? And after that you can call your cube, right? Cube, and you can type here this keyword say flux, right? Flux and dot data, okay? So this will extract the flux, right? You can see this is the, and you can also check the shape of this data cube, right? So we have shape, you can type 0, so it's z axis, 1 your y axis, and 2 your x axis, right? So this way you can do this stuff, right? So similarly, just extract the wavelength also. So just type here wave equal to cube, type here keyword wave, right? And give it a string and dot data, right? So wave, okay, so wave is your this much, okay? So now we'll doing the stacking process, okay? So now stack the fits Spaxel Spectra, okay? So for that I will type here a variable say called a stack a spectra, right? And then you can type here np dot mean, okay? So I want to stack by this method, okay? So just I am going to do by simple averaging, right? So first method, right? So for that I will type here nb.mean, so it will take the mean of your each flux, right? And then you can give your say, you can give your say flux, right? So flux, right? and then you can give that along which axis you want to get the mean. So you can type here, say axis equal to 1, right, 1 comma 2, right. So here you can see that I have axis 1, right, and we have axis 2, right. So you want to get the sum along your Spaxel, right, your the whole Spaxel. So for that you have given 1 and 2, right. Now we have done this much. So this will uh, so this will take mean of mean of uh, flux over over y y and x, right. So now our job is done. All right. So and then you can plot this spectra. So PL, so plot this spectra. Plot this spectra. You can type here PLT dot plot, right, and you can give here here your wavelength, right. So it's same for everyone, right. So every spectra, and then you can give a stack spectra, right, and you can give here say PLT dot x level. You can give say wavelength wavelength, and you can give y level as a flux, and you can give us say title you can give data cube stacked spectra, right, and PLT dot so run it. So here you can see that I have this spectra and this is the stacked. Okay, so this is the combination of your all spectra via a simple averaging, right. So you can also go for your median, right, median. So see how the spectra will look like, right. You can do so many stuff, right. So I will so many methods. So I'll just put here simple mean, right. This is how the spectra look like. So this is a simple so thank you and stay tuned for the next videos.